Hey everybody. So today, one of the things that we need to talk about is something called composition of functions. Okay, so before we look at algebraically how we're going to do this or what this might look like on a graph, I'd like to show you a little bit of a real world example here. So a little bit of story time. All right, so take a look at this. So we're at the doctor's office, and it says, suppose a patient is given 250 milligram injection of a therapeutic drug that has a side effect of raising the heart rate. Okay, so we're going to inject our patient with some sort of drug, and then the more drugs that are in the person's body, the higher the heart rate goes up. Okay, so this is an example of a function. So let's talk about just this function first. So this function, we'll call this function f. So what's my input value? So my input value is the drug, which they're calling Q, and my output value is the heart rate, which they're calling R. Okay, so here's a function, f of Q equals R. What's something that you notice about this function? So what I notice is the higher the drug level, the higher the heart rate. Okay, so this seems like a function. Does this follow a rule for a function? Seems like it, right? If you guys remember, a function for every input, there's one output. So there's no repeating inputs, and this seems to follow that. So if I look and I have 0 as the drug level, the heart rate's always 60. It's not 0 gives me 60 or 65. It's always the same thing. Okay, so we got a nice little function here. All right, let's jump down to the second table. So the second table, it says over time, the patient's body metabolizes the drug, and the level of the drug in her bloodstream falls accordingly. Okay, so now we have a second function. So in this function, we have called f again. So my input is t, and now my output is q. Okay, so let's talk about this function for a second. So as time increases, the drug level goes down. That makes sense, right? You're sitting in the hospital and you sit there for 8 hours, the drug level in your body should go down. All right, so before we go to our third table here, let's recap what we have here. So in this first one, our Q, our drug level, was the input, and then the output was the heart rate. In the second function, time is my input, and the drug level is now the output. So in the first function, drug level is the input, and now drug level is the output. Okay? All right. So now we're going to try to take those two functions and we're going to try to put them together. So that's what's happening in this third table. So if we keep reading here, it says, since the patient's heart rate depends on the drug level, so that came from our first equation up here, the heart rate depends on the drug level. And in the second one, the drug level depends on the time, then what that's really saying is we can combine these two tables and we can say that the heart rate depends on the drug level. Okay, so what we're going to try to do is we're going to kind of take out the middleman here. So instead of going from drug level to heart rate, time to drug level, we can kind of take out this drug level component and we can make a new function that just compares time right to heart rate. Okay, so let's look at this third function. So in this third function, we say f of t, so now my input is time, equals r. So if you notice in this third function, there's no drug level at all, but the drug level still plays an important role, right? The drug level is what's increasing the heart rate, but this third table says we don't really need to know that. We can skip that step and go straight from time to heart rate. Okay, so now in this last example, the time is the input, and then the heart rate would be my output. Okay, now let's look at this table down here, table 6.3, and let's see where they get some of these numbers. So if I look, when time is 0, they're saying the heart rate is 110. Okay, now let's see if we could have predicted that without using this last table. So how do they come up with that? So here's what they did. They took this function our second function here, and they said, okay, when time is 0, that means the drug level is 250. Well, what happens when the drug level is 250? Well, if I come back up to the top function, we can see, oops, sorry, technical difficulties. We can see all the way on the far right there that when my drug level is 250, my heart rate is 110. And that's how they came up with this down here. So they went from 0 and 250, and then they looked at table 6.1, and when the drug level is 250, they found that heart rate was 110. Okay, now let's see if we can find another one. So maybe we can do some predicting. Maybe it doesn't come out to be perfect numbers every time, but let's look at time equals 1. So when time equals 1, what happens? Well, somehow they figure out the heart rate's 100. So they went, time is 1. That means the drug level is 200. That's what table 6.2 tells us. And when the drug level is 200, if we look back up at table 6.1, what happens when the drug level is 200? The heart rate is 100. And that's how we came up with this value down here. Okay? So the reason this might be nice is if you're a doctor and you want to know the heart rate after, let's say, 5 hours, you don't want to have to go, okay, time, drug level, heart rate. You just want to know after 5 hours, what's the heart rate? And so we combined the first 2 tables into that third table. Okay, so this is an example of what's called a composition of functions. Okay, so let's talk about how we might be able to do this algebraically. So algebraically, I might give you 2 functions. So let's call the first function f of x. Let's just keep it simple. F of x is 2x plus 1. And then let's come up with a second function. Let's call him g of x. And let's just call him x squared minus 1. Okay, so we have 2 functions here. So I'm going to try to combine these functions. Okay, but before that, let's just start with something nice and easy here. Let's see if we can figure out how to find f of g of 2. Okay, so let's first talk about what the heck this notation means. So this notation means I'm going to find g of 2, and then whatever that g of 2 is, I'm going to plug that in to my f function. Okay, so first of all, let's talk about how to say this. So this, I would say f of g of 2. That's what I would say out loud. Okay, this is, remember, parentheses, when I'm talking about like multiplying 2 numbers, you know, this would be like 2 times 3, but that's not what we're doing with our function notation. So this is of f of g of 2. Okay, so how am I supposed to figure out what f of g of 2 is? So what I'm going to do, I'm going to first figure out what is g of 2. All right, so how do I figure that out? Well, this says 2 is the input of the g function. Then we go to the g function. I'm going to plug into 2 squared is 4, 4 minus 1, that'd be 3. So g of 2 is 3. Okay, so now, since g of 2 is 3, I'm really just trying to figure out what is f of 3. All right, well, f of 3, that means take 3 as an input and plug it into my f function. So 2 times 3 is 6, plus 1 is 7. So that means f of g of 2 is equal to 7. All right, I'm going to have you try one on your own here. So I want you to see if you can come up with g of f of, I don't know, 1. All right, so I'm going to have you pause the video, see if you can figure out what is g of f of 1. Pause. Okay, so what did you come up with? So the first thing you probably did was, well, let's figure out what f of 1 is. So I'm going to come up to the f equation, plug in 1, 2 times 1 is 2, plus 1 is 3. So f of 1 is 3. So now I'm just going to find g of 3. So I'm going to come up to my g function, plug in 3. 3 squared is 9. 9 minus 1 is 8. So hopefully you said g of f of 1 is equal to 8. All right? So pretty simple stuff. We're just kind of doing 2 things in a row. Now, I want to have a little side conversation about some notation, especially if maybe you're an IB student. There's another notation you might see for g of f of 1, and it's kind of goofy looking. So it kind of looks something like this, where it's g open circle f of 1. So you might see something that looks like that, okay? So don't worry about that too much, but I just wanted to show you that this open circle, it kind of looks like a multiplication symbol, but it's open. This represents of. So this would be g of f of whatever, okay? So kind of keep that in mind. You might see it in parentheses like this, and then with the number outside. So you'll see it a couple different ways, but the key is that open circle means of, all right? I like to write it like this. It makes more visual sense to me, but that open circle looks like it says golf, G-O-F, but it's really just a little open circle there. Okay, so the next thing I want to do is, I'm a little bit lazy. These are a lot of steps for me. So I want to see if I can come up with a quicker way to do this. All right. So here's what I want to do. I want to come up with an equation for f of g of x, a brand new equation. Well, how am I going to do this? What is this saying? This is saying take g of x, the entire function, and shove it into f. So I'm going to take this entire function and shove it right in there where that x is. That's what I'm going to do. Okay? Well, what is that going to look like? So I'm going to take all this, x squared plus 1, x squared minus 1, I'm going to shove it right in for that x there. So it's going to look like this. 2 parentheses x squared minus 1, close parentheses, and then don't forget about my plus 1. So all I did was I took this function, x squared minus 1, and I plugged it in for that input, which was x. All right, so now I'm going to simplify here. So I got to distribute. So 2x squared minus 2, and then don't forget about your plus 1. So when I simplify this, I get 2x squared minus 1. So f of g of x equals 2x squared minus 1. Okay, now, why did we just do that? What's the point of that? Well, help me out for a second. Let's say I want to find f of g of 2. All right, well, we already found it over here. How did we find it last time? We took 2, we plugged it into g, we got 3, we took 3, we plugged it into f, and we got 7. Well, now, how can I find f of g of 2? Well, now, all I have to do is just plug it in my f of g of x equation. So I'm just going to plug in 2 right here. 2 squared is 4, 2 times 4 is 8, 8 minus 1 is 7, which is what I just got over there. Okay, now you might be thinking, well, this seems like a lot more work, but if I have like 27 things that I want to plug in, instead of having to do multiple steps in a row, now I have a nice boom function there. All right, so I'm going to give you a second. I want you to come up with g of f of x, this new equation. Is it going to be the same as f of g of x, I wonder? I don't know. All right, so take a second and see if you can come up with our new equation, g of f of x. Ready, pause. Okay, did you figure it out? So what does this tell me to do? I'm going to take f of x, this entire equation, 2x plus 1, I'm going to shove it in right there into my g function. So this is going to be parentheses 2x plus 1 squared minus 1. So I took this whole piece and I shoved it right in there where that x is. Now I have some FOILing to do. See if I can do this. 4x squared plus 2x plus 2x plus 1 minus 1. 4x squared plus 4x plus 1 minus 1. They cancel out. That's kind of nice. All right, now, how do I check to see if I did this right? Well, why don't we just see if we can find g of f of 1. Okay, So doing it the long way, we got 8. So if I did this right, I should be able to plug in 1 right here, and I should get 8. So 1 squared is 1, 4 times 1 is 4, 4 times 1 is 4, 4 plus 4, bingo, I got 8. Smiley face. Okay? So that's how we're going to take two functions and put them together. So this is called a composition of functions. Now, why is it called that? Well, because really we're composing a new function. We're creating a new function. So we're taking two functions and we're putting them together. Okay? All right. Last thing, I'm going to go back to sharing my screen here in a second. Maybe I'm not. Let's see here. Okay. So last thing, I want to look at these graphs here. Okay. So if you want to take a second and draw these, you're welcome to do that. If you just want to kind of follow along on your Chromebook, that's fine too. All right. So let me clear off what I have here. Okay. So let's take a look at these graphs here. So what in the world is going on? Well, first thing you should see is we have two graphs here. We have an F graph, which is like this curvy looking one, and then we have this G graph, which is the spiky mountain range looking one. Okay? So here's that notation up here. Do you remember what I said this was? So it looks like fog of 5. So what is that really saying? So this is really saying F of G of 5. That's really what that's saying. Okay. I like this version better the way I wrote it, but I kind of want to keep showing you both just so you can see both. So how do I find fog of 5, F of G of 5? Well, I'm going to go to my graph. I'm going to find G of 5. Okay. So G of 5, can you find it? So G of 5 is 0. Okay. How do you know? When you plug in 5 over here on the right, my pointer can't quite get there. G of 5 is 0. It's right on the x-axis. Okay? So if G of 5 is 0, then really I'm looking for F of 0. So now I'm looking at my curvy graph. F of 0 looks like it's right here at the origin. So F of 0 is 0. So that means that F of G of 5 would also be 0. Okay? And that's how we did that first one. So I'm going to give you a chance to see if you can do one on your own, or maybe I'll do one more with you. Let's try number 8. So number 8 is F of G of 1. So I'm going to write it the way I like to write it, F of G of 1. So how do I do this? First thing I'm going to do is find G of 1. G of 1, so that's my mountain range graph. So 1 is my input. The output is up here. That's 2. So now I'm looking for F of 2. So now I'm on my curvy graph. So F of 2 is down here. F of 2 is 0. So that means that F of G of 1 is 0. Okay? So I'm going to go ahead and ask you to try number 3. So I'm going to have you pause the video and try number 3. Ready? Good luck. Okay, so let's see if we can do it together. So F of G of 0, so number 3. So F of G of 0. So first thing I do is find G of 0. G of 0 is 0. I'm right here at the origin. So then I'm going to find f of 0. Ah, dang it, I lied. Let's try again. All right, so number 3 is f of g of 0. So g of 0 is, g is this pointy one. So when I plug in 0, my output is 1. So now I really want to find f of 1. And f of 1 on our smooth curve here, f of 1 is right here, which is equal to 1. So f of g of 0 is equal to 1. Okay, now did you see these weird looking ones over here, like number 10? So number 10, it's no big deal. They want to know f of g of 4. All right, so that's f of g of 4. So it looks a little gross, but it's really not all that bad. So what am I going to do? Well, first thing I'm going to do is find g of 4. So 4 is my input. It's my g graph here. The output there is -1. All right, so now I'm looking for f of -1. So f of -1, so my input's -1. My output on the f graph is up here, that's at 1. So that's f of 1 is now what I'm looking for. And f of 1 is right here, which is 1. So that means f of g of 4, all of that is equal to 1. Okay? All right, so that's going to do it for our composition of functions. So you have a little bit of homework that I need you to try. If you need help, feel free to let me know. We can do some office hours together. But thanks for tuning in, and don't forget I'm here for if you need anything. Have a good rest of your day.